So in this video, we're going to take a look at how we can open and read files in x86. And to be able to do this, we're going to be using system calls. We've seen system calls sort of off and on through our x86 programming, but now we're getting to the point where we're really going to dive into system calls to better understand how we can interact with the operating system itself. Because generally, this is one of the main things that you're going to be doing when you work at such a low level is requesting resources from the operating system and just overall interacting with the operating system itself. So understanding that, let's discuss a little bit about how we can understand the system calls for opening and reading files. And I really want to guide you through the process of this because it's helpful to understand how this information is found, because otherwise it just seems like I'm pulling the information out of nowhere and you might be a little bit lost. So I'm going to go over to my browser here and we're going to take a look at a few different resources for understanding some system calls. The first one is going to be this x86 system call table. This is really helpful for determining which value we need to put into EAX in order to create a particular system call. So we saw throughout our videos that we put the 1 into EAX to do a system exit, right? And we would put into EBX the exit code, the exit status code. And you can see here that it requires something in EBX, that being an integer value. And that was the exit status code that we were putting in. So you can see that we can read this table pretty easily to understand how we can do these different system calls. Now, in this case, I want to open a file, which would be done through sysopen. Now, sysopen has an EAX value of 5, so if I want to do an open system call, it stands that I should move a 5 into EAX. Now, the next thing we need to figure out is what do we need to provide to the system call to be able to actually get it to function. It looks like we need some sort of character pointer in EBX, an integer in ECX, and an integer in EDX. Now, this doesn't give you the information about how you actually are going to, like what values these are, what they are corresponding to, but you can figure that out pretty easily by just clicking on the name here, which should take us to the man file. It actually doesn't here, but we can just look up open man, and I'll put these links into the description as well, but it will take you to the manual page for the open system call. Now, you'll see here that there's two different ways that we could actually do this open system call. There's one with the path name and flags, with the path name, flags, and mode. Now, if you read through this manual file, you'll find that the path name is the file that we're trying to open. So it's the location to the file that we're trying to open. The flags are indicating what we want to do with the file. So for instance, if you want to just read the file, you could set the flag read only, which will just give you read privileges on the file itself. And then mode T is actually an optional argument. We don't always need to provide it. We only provide it in circumstances where we are creating a file. So we could create a file using the open system call. If the file doesn't exist already and we set the right flag and flags, so we could set a flag for creating a file, what will happen is if the file doesn't exist, it will create the file for us. And this mode basically dictates what permissions are set on that file when it's created. So it's a set permissions on the file itself. Now, we aren't going to be creating files in this, just opening them. So we're just going to worry about this top level one, which requires a path name and flags. And specifically, we know that the path name goes into EBX and the flags goes into ECX. Now, really, it just works sequentially, right? The first argument goes into EBX, the second one goes into ECX, and so on like this. It's just helpful to see this reference the first time around to understand where that's coming from. So we now know that we need to put the path name into EBX and we need to put the mode into ECX. So let's go ahead and do that. So to be able to get a path name, I need to put the path name into my data. I'm going to point it towards just some file on my computer. Doesn't really matter what the file is. You can point it to any file you would like. So just go ahead and select any file on your computer, put its path in here. And then what you're going to do is you're going to move into EBX the path name variable. Specifically, this moves the address of this variable here into the register, right? It's giving it a pointer, exactly what we were expecting based on that system call. Now, the next thing that we need to put in is into ECX, we need to put in the flag. So we want to read the file. So a read-only flag would be perfect. If I were to take a look at the man file, I could find that inside of here gives me all the different flags that we could possibly have. And one of the flags is read only, which is an access mode, which will open the file in read-only mode. Now, the problem here is that oRead-only is really like a C constant. So we want to be able to convert that into an integer because that's what we really need to provide. To do that, we have to go into this fcntl.h file, which is where all of these different values are defined. And we'll see here that read only is defined as 0. Now, if you're wondering, why did I know that this was an fcntl.h, it actually tells you right here that it is. So all that information is inside of the man file. So you could find that relatively easily through that process. But generally, that's what we're going to do. We're just going to look here. We're going to say, okay, so this is 0. If I wanted like write only, it'd be this one here. So that'd be 1, for example. But since we want to read, we're just going to add a 0 into ECX. And then we do our interrupt. So this now has everything that it needs to do the system call. When it does this system call, it returns the result back to us in EAX. So EAX is going to have the result of this system call. The result from the system call is an integer. That integer is what we call a file descriptor. It's a unique identifier associated with the file that we can use in other system calls to be able to manipulate that file in some way. So for instance, when we want to read the file, we're going to provide the file descriptor for the file. And then Linux will be able to go and it will say, oh, that file descriptor number associated with this file. So we'll run the operation on that file. Let me show you what that actually looks like. Let's go ahead and get this code assembled. So I'm going to do an assembly through NASM. And I'm going to use GCC to compile it. Again, you can use just like a linker approach for this. You just have to change the label back to _start. I just like using GCC just because it's a simple sort of command here. So we'll use that for now. And I'll just GDB first. We'll go into the layout ASM. We'll break at main. Oops. I'd have to spell it correctly. So we'll break at main. Then we'll run and we'll step into this here. So you see that we step in. Now we can actually take a look at what's at that address, right? If we really wanted to see the actual string itself, right? So you can see that it actually, well, this is just a hex, right? So we can convert it to string using 10s like this. And we'd be able to see, you see that the whole path is written in there, right? So that gives you the way of being able to actually view that information. But yeah, generally when we step into this and once we run that system interrupt, it's going to do the system call for us. And now inside of EAX, we should see the result, which in this case is 3. So 3 is the file descriptor that's associated with that file that I just opened. So that's the file descriptor. Now we can use that file descriptor to read data from the file, and that's what we'll take a look at here now. So if I come over to my terminal, I want to do a system read. So again, the question is, what do I need to put into EAX in order to do that? Well, the answer is I need to put into EAX the value 3. The file descriptor needs to go into EBX. It's currently in EAX because that's where it got returned to. So I'm going to move into EBX EAX. And then I'm going to move into EAX the value 3, since that's the system call. Then we go back here, we say, what else do we need? Well, we need some sort of char star and some sort of size _t. I'm going to come over to read here. I'm going to take a look, and it says that I need a buffer as well as a count. The count is the number of bytes that we want to read from the file. And when it reads those bytes from the file, it puts them into the buffer. So to create a buffer in x86, what we do is we create our BSS section. So we create the section.bss. And inside of this section, we're going to put in a buffer, and we're going to reserve some bytes inside of it. Now, the question is how many bytes? And the answer to that is really, how many bytes do you think you're going to be inside of the file? You could put more bytes than what are inside of the file. You could put the same amount of bytes that are inside of the file, but you can't really put less, because if you put less, you won't read the whole file. This really just depends on your goal. If you want to read 10 characters from the file, you can make this 10. If you want to make it 20 characters, you can make it 20, right? If you want to read the whole file, just make it something that is large enough to contain the whole file. In my case, I don't know how much is in this file. I'm just going to use 1024, and I think that that's probably way big to be able to actually take that data. So it should be sufficient size for that to work. Okay, so that creates our buffer. So we want to put that buffer into ECX, right? So we come over here, we want to put that buffer into right here, ECX, right? So let's go ahead and do that. So we're going to move into ECX, the buffer. And then EDX was, again, the size. So how much data we wanted to read from the file. So I'm going to say 1024. That will fill the whole buffer if, there is that much data to read. If there isn't that much data to read, well, then it will just fill as much as it needs to and then move on. Now, when we do the system interrupt here, what's going to happen is it's going to do the read. It's going to return back to me the number of characters that it read from the file. That should be usually equal to this value. The situations where it's not equal to that value is if we read less than that from the file because there wasn't that much in the file, or if we reach the end of the file, in which case we'll get back a value of 0. So if you ever want to iterate a whole file, what you would do is you would iterate until that value is equal to 0. And we'll see that sort of process. I'll show you some more examples of this because really I just want to get you, associated and understanding the idea of reading files. And then we'll dive into a lot more of the intricacies around reading files and how we do that sort of process. So for now, let's just take a look at this result because now we've read from the file. So let's go ahead and see what that looks like. Let's get an understanding of this sort of process. So do a layout of ASM, we'll break at main, we'll run, and we'll step into our application. So we do the interrupt to read. At this point in EAX, we have a value of 3, right? And then we go ahead and we move the 3 into EAX. We moved the file descriptor to EBX. We put our buffer into ECX. We put our size into EDX. We do our interrupt. And then we ask the question, where is the data? Well, the data is inside of the buffer. The buffer is at 804C04C. And I know that because that's what I moved into ECX. So that must be the register of it. So how do we see that data? Well, we do X over, and then we just put in, some amount of data to read as a string format is what we're expecting it to be. So 804C04C. And as you can see, this is the data inside of the file. So we can actually see that that data was read from the buffer, and it's now gone because I've closed it off by accident. Let me just get that up one more time for you so that you can see it in full detail. So you can see here that there is some data that's been read into this buffer. And I could prove to you that this is actually the data that I think it is, right? So if I go up one directory here, I think I need to go up one more. I have this system design folder, and I have this database file. This is what I'm reading, right? So you can see everything from this file is now inside of the buffer that we have created, right? So we see that sort of result very clearly. So we did actually successfully read from the file. Now, last sort of thing that I want to show you here is we want to exit the program, right? So we move a 1 into EAX. Remember, we might want to move in a status code into EBX. So I'll just put in a 0 in this case, and I'll interrupt ADH. At this point, the data from the file is stored in the buffer, and you can safely exit the program. Now, when I run this program, it should run without any sorts of problems, right? So we should be able to just sort of run it, right? So I could just say /first, and you see that it did run. If I have echo at the exit code, I get the value of 0. And nothing really happened because we can't really see any of these results because they're all just kind of stored away in memory. But if we were to do things like printing to the screen using our C functions, we would be able to see the results of this sort of idea, right? But for now, this just gives you an idea of how you can open files and read files in x86 assembly. Like I said, we'll continue to discuss more concepts related to reading and writing files, and we'll continue to build on top of these concepts, but this gives you the basic foundations of reading files as well as opening files in x86. So thanks so much for watching, and I'll see you in the next video.